Looks like the stream is going. Hi everyone, TigerHawk T3 here. Today we're going to look at the collections module in Python. So here we go. I'm going to go in alphabetical order and only do the particularly interesting and useful ones because there's a bunch. Maybe I'll come back to it later and do the more unusual stuff. Probably not. Chain map. A chain map class is provided for quickly linking a number of mappings so that they can be treated as a single unit. I'm not going to use that. Chain map. Lots of chain map. Recipes. Yeah, no. Counter. Here's what we're going to do. If you've seen my previous streams, you will probably be familiar with counter. I used it a bunch in the loot parser because we were parsing a bunch of loot. Get a shield, get a battery, and then we wanted to count everything, and that's what you use a counter for. This is a class in this module that a lot of people aren't familiar with, don't know it exists, so they end up trying to implement their own, and it's generally a little harder to use. So yeah. So we're gonna check this out. So C equals collections dot counter. Actually, let's make let's start with a list with A, B, C, C, C. Okay, and how about 5 also, because we can do that. Now let's make a counter object and pass it our list. Now, what is this counter object? Now we have a counter object, and you'll notice that it has the curly braces around it. This is because it's similar to a dictionary, has a lot of the same methods and structure and behavior, but it has a few extra things, like C plus collections dot counter. Oh, that's not a plus. So if we take our counter that we already made and we add it to another counter of the same thing, we'll get, you know, 2 of them. 6 and 4 and 2 and 2. So there's something cool. It's pretty darn useful. One interesting thing to know about it, I guess I don't want to call it a flaw or a bug necessarily, is that if your counter has values with 0 or negative counts, they might disappear. I think it's if you add them or subtract them or something. If you add counters or something. I think the workaround was to create a new counter and update it with new values. I'm not sure why they chose to do that, but it is annoying. Counts are allowed to be any integer value, including 0 or negative counts. Yeah, that's true. So you can minus C. Let's do that twice. No? Then they're gone. See? collections.counter minus C. Oh, I forgot to create one. See, this should have had a counter with negative values. Something like this. But instead they're just gone. They disappeared. Which is annoying, I think. So the solution was C1 equals collections.counter. How did I make a -1? Let's just make a -1 as follows. Negative, 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 negative. There. So this is our negative counter. And if we have collections.counter, let's see if it works this way. Plus C1 is empty. Let's make another counter object and do C2.update C1. Huh? Now let's look at C2. Ah, now there it is. So that's something. That's what we saw on the stream where I was trying to get net values, and sometimes they were negative and they would disappear. They would be gone, and I would be like, where did they go? And the answer is this happened. So watch out for that if you plan to have 0 or negative counts for anything in your counter. Because they might go away when you add or subtract various counters. That's interesting. So there's an elements. Ooh, I wonder. Elements method. And this gives you an iterator of. What's that? No. Nope. No, 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 no. Ah. What's going on? Print star. There we go. C dot elements. And the elements method gives you an iterator of all the elements as follows, in arbitrary order. That's what we've got. Most common does the following. Gives you a list of tuples with the most common ones first. And if you want only the actual most common, you pass it 1, and it only gives you 1 tuple. Could be handy. It's basically it's basically sorted C with a key of C.get. And then we have the least being B and 5 because they're the same. And then we have A and C. That's what that is. And passing an argument is basically how we passed, 1. I only want one of them. We have that. C being this. we could do c.items, and that will give us the object and its count. And c.get, now we will have to do something else with this. Lambda x, c.get x0. There. Fantastic. And I scroll down. Oh, someone is in chat, and I am noticing. When did this happen? 59, a couple minutes ago. Cool. I can't, I'm sorry, I can't pronounce your name because it is, looks like kanji, which I am not able to read. Saying cool haircut. Thank you. I actually have gotten haircuts at various points a few weeks and months ago. Just kind of trimming split ends and stuff. I don't know if it makes much difference, but I do it sometimes. Where am I? What am I doing? Okay. Most common subtract. Haven't used that one before. Like dict.update subtracts counts instead of replacing them. Oh. What do we have for C, C1, and C2? Let's look at those. C1 plus C2 is empty. We don't want that. How about C1 minus C2? Also empty. We still don't want that. How about C1 dot subtract C2? Is this in place? It is. So it will modify the thing. Fine. So C1 and C2, why are they all 0 now? That's odd. Oh, because it's minus a negative. -2 minus -2 is 0. So that's what we get there. Let's put that back to normal, and instead of doing C1 equals C2, I don't want that. I want C1 equals collections dot counter C2. There. I want them to be equal to each other, but not be references to the same actual counter object. So I can subtract, because minus doesn't work. So I had C1 minus C2 being an empty counter. If I wanted to actually subtract them, you have to use the subtract method. Let's do C1 dot update C2, and C1 is adds them. So it would be nice to not have something that mutates your objects in place, which is generally what plus and minus are for. But if you want to do like C1 equals C1 plus C2, that would be C1 dot update C2. And if you wanted to do C1 equals C1 minus C2, you would have to do C1 dot subtract C2. I'm not sure I like that, because then it takes away the option of just doing, you know, print C1 minus C2 or something. So if you don't want to overwrite your original objects, you would have to create a temporary placeholder sort of thing and then update that with both of the things that you're interested in. So that's not great, I think, but at least there's a way to do it somehow. In the documentation, several mathematical operations are provided, blah blah blah. Each operation can accept inputs with signed counts, but the output will exclude results with counts of 0 or less. You'd think it would be just 0, maybe, but no. It also takes out the negative ones. So, yeah. You can get an intersection and a union. That's cool. That's something you can do with sets. The intersection of two sets and the union of two sets. That's what that is. You can also do that with counters. And when you do the intersection, it gets the minimum of each counter that you intersect. And when you do a union, it gets the maximum. So it's actually just, yeah, I was going to copy and paste it in. No. The example in the documentation is two counters with that each track an A and B. An intersection with the ampersand is chooses the values with the lowest count from each, and union is the highest count for each one. So if one counter has A equals 3 and another has A equals 1, you'll get 3 with intersection, or sorry, you'll get 1 with intersection and 3 with union. Okay. It's kind of a max for each. It's kind of a handy shortcut, I guess. That's interesting. What's my C? C dot update A and -3. Okay, let's do that. Now what is C? Now it has positive and negative things. So we can do plus C and find all the positive stuff, or negative C and find all the negative stuff. That's cool, because the negative value here turned into a positive, and everything else got excluded, because it does that. Note, counters were primarily designed to work with positive integers to represent running counts. However, care was taken to not unnecessarily preclude use cases needing other types or negative values. To help with those use cases, this section documents the minimum range and type restrictions. Counter is a dictionary subclass. That's cool. Most common requires that the values are orderable because it has to sort things. That's not very interesting stuff over there. See also bag class in Smalltalk. Wikipedia entry for multisets. C++ multisets tutorial with examples. That's cool. It's other languages. There's a reference to a book here. The Art of Computer Programming, Volume 2 by Donald Knuth. That's, yeah. Of course, right? Where are we on time? How about one more thingy. This is something I have never ever used before in this language, but I have used a similar thing in Java, and that thing is a queue, a double-ended queue, a linked list. It doesn't say linked list here, but it is a queue. I guess linked list is just an implementation. But what it is a double-ended queue. Double-ended queue. Technically, queue is like this, but maybe that had confusion with dequeue to remove something from a queue. And it's pronounced deck, like a deck of cards. I should probably give it an iterable. Oh, if it's not specified, it's empty. Okay. So what's D? It's a deck. It's empty. The thing about decks is that I think they're pretty much linked lists. A linked list is one of these concepts in computer programming that maybe you have used or learned about or heard of, perhaps. I've never used one before in Python. It just doesn't really seem necessary. The standard list type prefers that you append and pop from the end of the list, because if you try to do that with the beginning, if you insert at the beginning of a list or pop from the beginning of a list, then it needs to kind of rebuild and rearrange it to have a new starting point. But a linked list is builds a list with by linking all the objects. It's kind of like a scavenger hunt. A regular list or array would have just like a shopping list. Here's all the stuff you need to get. But a linked list is like a scavenger hunt where you only get one item to locate, and once you locate it, it has a clue to the next one. So if you want to add to the beginning of this linked list, all you have to do for the scavenger hunt is instead of giving the person who's looking some item, you put that clue on your new first item, and you give the person a different first clue, and that's it. You don't have to rearrange anything else. And that's the strength of linked lists. You just make and break links to change the structure of the list. Now, the drawback of this this structure is that what if you want the third item? You have to look through the first and second to get to the third one. So if you want to access anything in the middle of the list, have fun. And especially if it's at the end of the list, if it's just a kind of basic implementation of a linked list, then you have to start at the beginning and iterate all the way until the end. So not ideal for that use case. This is a double-ended queue, so a deck. So I think we can go from the back if we want. We can start at the end and go in either direction. But the idea is using it as a queue. So we can add from one end and take out from the other end, or either direction, and not necessarily storing a bunch of stuff and locating bits and pieces. For that, we want a list that we can just index. So we have methods like append and append left to add something to the right side of the queue. That's the end. That's like the standard list append. And append left, which is similar to insert at 0 for a regular list. There's clear to clear it. So let's get a regular list as well. Let's do that. So l.append 3, d.append 3. Let's look at L, let's look at D. That's great. D.append left with no underscore. I don't know. Notice how the counter is with a capital C and the deck is with lowercase d. It's some inconsistency that I don't like. Anyway, append left, how about 1? And let's do l.insert at 0, 1. Correct? Did I do that right? Yes. So this operation was more time-consuming to carry out than this one, and will become more so when L grows to be very large. So if you're going to be working with both ends of a list, might want to try a deck. Not really something I have to do very often. There's count. I'll count 3. Let's just do 1. We have 1 of them, and our deck.count, and it's the same thing. Copy to create a shallow copy. That's cool. Oh, new in version 3.5. I'm currently running the Python interpreter version 3.4. So the so this won't exist. It's not a thing yet. At some point, I suppose I will install 3.5. There's actually 3.6 coming out end of this year, I think. So maybe I'll upgrade to 3.6 when 3.6 is out. 3.5 has some cool things beyond this deck.copy method. It has a faster os.listdir, which is scandir. The function to get a listing of all the files and folders in a directory is much faster in 3.5 because it uses a new technique. It's pretty cool. It's like 10 or 20, 7 to 20 times faster. Significantly faster. I mean, it's not slow for the old versions, but if you have a very, very large folder, it could end up making a difference. A noticeable difference, I should say. And the other cool thing is extended unpacking syntax. In Python 4, you cannot do this. You get a syntax error. You can only do one of those. In Python 3.5, they were like, why is this a syntax error? Is it too hard for the interpreter to understand? No. It can be clear and unambiguous. So you can do that sort of thing. You can read more about it, Google something. 3.5 extended unpacking, something like that. So there's no copy in 3.4. There is count as of 3.2, which I have, which we did. Extend and extend left. So let's do d.extend 5 and 6. How about? And let's do the same thing with L. And look at both, and we have 1, 3, 5, 6. Is there... I don't know if there's a similar method for lists, extend left. See, this is why decks exist. D dot extend left. How about 9 and 8? I don't know. Now let's look at D. It has 8 and 9. So it does it in that direction. Interesting. So it adds 9 to the front, and then it adds 8 to the front. Extend the left side of the deck by appending elements from iterable. Note, the series of left appends results in reversing the order of elements in the iterable argument. That would have been good to read the manual before trying it, but that's fine. I mean, I see it now. There's an index method that returns the position of x in the deck at or after index start and before index stop. Raises value wherever it's not found. L dot index 3. The 3 is at index 1, index 0, index 1, and here's what we're looking for. And for decks, this is only in 3.5, so I'm not going to show you that because it'll just be an error. Insert. Insert X into the deck at position I. Remember how we used the L.insert method over here? In 3.5, decks have an insert method, so that's cool. Pop. That's a good one to show. What's D? D dot pop. Gives us 6. Now let's look at D again, huh? There's no 6 over there. It removes and returns to you this element. What's L? It also has 6. Let's do L dot pop. It's gone. See? It's not in there anymore. Now let's do a deck thing. D dot pop left. Remember we had 8 at the beginning. Let's look at D again. The 8 is gone. So let's look at our L and do L dot pop. Can take an argument for which one you want. We can say we want to pop 0, and there's 1. L equals L times 3. Okay. 3, 5, 3, 5, 3, 5. Great. L dot pop. Let's do 0, 1, 2. Let's pop 2 there. So we will get 3 returned to us and have an L remaining of 3, 5, 5, 3, 5. 3, 5, 5, 3, 5. Beautiful. It did what I expected it to do. That's good. Remove. Let's have this as well. L dot remove 5. It removed the first 5. And then we were left with the second and subsequent ones. Now let's do it on the deck. What's in this anyway? D dot remove 1. And it's gone. It didn't do too well. It's gone. Reverse. Reverse the elements of the deck in place and then return none. D dot reverse. Returns none. None is a value that is not displayed, is not sent to the standard output when you are using the interpreter. If you want to actually see none written there, you would have to print. So we can do that. That's what it is. Let's reverse it back, and should be 539, and it is. Rotate. Rotate the deck n steps to the right. If n is negative, rotate to the left. Rotating 1 step to the right is equivalent to d dot append left, d dot pop. Let's take a look at that. Rotate. So we took the 9 over here, and we moved it to the beginning, right over there. And this is equivalent to d dot. We're gonna pop the last one out, right? That's what we did. We took out the 9, and we want to put it at the beginning. So that means we're going to I turned on insert. D dot append left. D dot pop. So we remove the last one, and we put it on the left. And now we should get 395. 395. There's a maxlen attribute, read only. And it's none, because I didn't specify one. It's none. Because you can specify a maximum size of your deck, so that when you try to add more elements to it beyond the maximum size, it gives you an error, if you want. Deck support iteration, pickling, being sent to the len, and reversed built-in functions. You can copy them with from the copy module, copy.copy and copy.deepcopy. Membership testing with in, and subscript references to access. D0 will give us 3, because it's the first one, the 0 width. It is the element that is 0 distance away from the beginning. That's why it's 0. Indexed access is O of 1 at both ends, but slows to O of n in the middle. Now, technically, it would only be O of half of n for the middle. D1. When we do this, it had to look at either the first or last element, and then track inward until it arrived at the element we wanted. So I suppose it can tell, it looks at the length of the thing and then says which end should we start from. And so if you access something in the very middle, it'll be like, well, whatever, and then it'll start from either end. Then it has to go through at least half of the thing until it gets there. But that's still O of n, because we can get rid of things like half, n plus whatever. It's just n, because it grows exactly as fast as at the same rate as the deck itself grows. Half doesn't matter. For fast random access, use lists instead. That's right, because that's what they're for. Starting in 3.5, decks support add, mul, and imul. So you can multiply decks, I guess. D times 3. Can I do that? Nope. Unsupported. Because I'm not using 3.5. D plus D. Unsupported. Because I'm not using 3.5. But when you do use 3.5, and you have a deck, you can add them together or multiply to get a larger deck, or imul. I don't know what that is. I don't know what the difference is. Deck recipes. Things to do with decks. This is like if you have a bag of crackers or something, sometimes they include a recipe that involves the product in some way. Like, it's legit, you can totally make awesome food with this, sort of. Like a bag of jelly beans or something will include a recipe for cake, and all you do with the jelly beans is sprinkle them on top of the cake. And it's like, is that, like, really? Like, you can make food and then toss this stuff on top, and it's totally part of this complete breakfast. Not an important part. It would still be complete if you removed the sugary cereal, but what else have we got? So that looks like the end of interesting stuff to say about dict. 40 minutes. Maybe we'll continue the collections adventure in another segment, because there's cool stuff like default dict, name tuple, which I have never used. Default dict I have used, pretty good. And order dict, which I have also never used, but maybe you would want to try it at some point. And a few other things: user dict, user list, and user string, which are just wrappers around those classes to make them easier to subclass. The need for this class has been partially supplanted by the ability to subclass directly from dict, so it was a workaround to resolve a problem that no longer exists. However, this class can be easier to work with because the underlying dictionary is accessible as an attribute. I don't know what the point of that is anymore. Need has been supplanted, need has been supplanted, need has been supplanted. Partially supplanted. So dict, list, and string can all be subclassed now, but we still have these wrapper classes because. Order dict, name tuple, and default dict. Neat. So I think that's the stream for today. Thank you for joining me. Person whose name I cannot pronounce, my apologies. And that's it for today. Saw some cool stuff from the collections module. It's a really handy module, even if the naming conventions it uses are all over the place. Camel case, snake case, lowercase. It's like whatever. We don't care. I think some of it is. It's not that they don't care. It was someone suggested, how about we make a new class called this, or a new data type, just like suggesting in a random email for the mailing list, and people were like, sure, sounds good, and they keep referring to it by its original suggested name, which the author might not have thought about very hard or checked whether it followed naming conventions, and that's what it ends up being. Oops. Should probably change that. They could probably just alias it, provide two references to the same thing, and then that would be, I think that would be good. If in some future versions of Python they could start aliasing certain unconventionally named classes in this module with conventional names. And then maybe a few more versions down the line we could take it out. No, we can't really take it out, but it doesn't really hurt anything to have two references for the same object. Whatever. And then we could just say the documentation could be changed to say the one with the one that follows naming conventions is the actual thing, and then in a little note it might be this used to be called something else and it's still accessible as that, but don't do that because the naming convention is different. But tomorrow video game something, I'm not sure. There's a new Humble Bundle out with what do we got? A Revel Mode Humble Bundle with Revel Mode games. I don't know what they are. Disco Dodgeball, Nidhogg, Choice Chamber, Golf with Your Friends, Skullgirls, Spelunky, and Roguelands. Those are for the two levels. And then there's another level, and you get Rocket League. Now there's a pay what you want for the first three, and for the next four, pay more than the average of currently a little over $5. And to get Rocket League with those, it's $15. So that's nearly $10 for one game. It goes for 20 usually. So I guess it's a deal of some kind if you wanted that. I probably won't get that level of, of bundleage. But we shall see what I will do tomorrow. And we shall see what I do afterward. At least day after tomorrow is probably going to be more collections stuff. Because, I mean, default dict is cool, at least. Maybe name tuple and order dict, I'm not, I don't quite see the use for necessarily, but I will show you them. Because, I mean, I've heard of them and heard people recommend them, so it's not just some random thing that happens to exist, but nobody cares, really. So that will be the next couple days of streaming. And, thanks again for joining me. Person with name and kanji characters. I don't know how to read that. And I will see you next time. Have a good one.